The topic for this video is stoichiometry. The essential questions are: what is stoichiometry? How can you predict how much product will be made in a chemical reaction? And what is the relationship between the mass of the reactants and the products? So stoichiometry, when we're talking about this, we can kind of think of cooking as being like chemistry. So in cooking, you take a bunch of ingredients and make something. In chemistry, your ingredients would be the reactants. You follow a recipe in cooking, and in chemistry lab, we would follow a balanced equation. In cooking, you're going to measure things using cups, teaspoons, and tablespoons. In chemistry, we measure using moles, grams, and liters. So the actual word stoichiometry is Greek, and it means to measure and to balance. So we're going to look at an example where we have hydrogen and nitrogen making ammonia, and it's already been balanced for you. And those coefficients can be translated into moles. So 3 moles of hydrogen plus 1 mole of nitrogen makes 2 moles of ammonia. Okay, and I know it doesn't just add up together, but if you think about if you're making a batch of cookies or a cake, in a cake you would add like maybe 2 eggs, 2 cups of flour, a cup of sugar, and some other various ingredients, and you end up with only 1 cake. So it doesn't necessarily just add up because you're combining your ingredients. However, if you took the mass of your reactants in grams and added it up, that should equal the mass of the products in grams. So this is going to be our strategy to solve stoichiometry problem. The first one is on your given, change it to moles if it's not already in moles. The next step is to take the moles of the given and change it to moles of what we want. And that's called the mole ratio. And the last step is to take the moles of what we want to whatever the question is asking for, whether it's grams, liters, molecules. We know how to change stuff into moles, and we know how to change moles into grams, liters, and molecules. So we're really just adding this middle step here. Look at this example. It says how many moles of hydrogen gas are needed to react with 0.48 moles of nitrogen. In order to do this problem, we have to have a balanced equation, which I've given you at the top. Okay, so remember, this is dimensional analysis. We're going to use our CUS method. So K is your known, U is your unknown, which is moles of hydrogen. We're going to set up our tracks, and I'll show you where those conversion factors are. So our known is 0.48 moles of nitrogen, and remember we put that over 1. Draw our line, and then moles of nitrogen needs to go on the bottom next. Okay, so the next thing I want to do, it's already in moles, so that was the first step. I want to change it into moles of hydrogen. So I'm going to put moles of hydrogen on top, and it's really important that you use your labels here, because otherwise it can get very confusing. We can find the numbers to use just looking at our balanced equation. We're going to use the coefficients. So in front of the hydrogen there's a 3, so I'm going to put a 3 in my equation. In front of the nitrogen there's nothing, which counts as a 1, so I'm going to put that in front. Then now I just do what I've always done. I'm where I want to be at the end. My moles of nitrogen cross out. I want moles of hydrogen, so I'm done. I multiply across the top, divide across the bottom, which is just 1s, and I get 1.4 moles of hydrogen. Okay, so that's the simplest way. That's just step 2, changing from moles of one thing to moles of something else. So if we look at how many moles of ammonia will be produced from the reaction of 2.8 moles of hydrogen and enough nitrogen. So my known is 2.8 moles. My unknown is the moles of ammonia. I'm going to set up my tracks. 2.8 moles of hydrogen is my given over 1. I want moles of hydrogen on the bottom, and I'm going for moles of ammonia on top. So again, we're going to go back to the balanced equation at the top of the screen and use the coefficients. There's a 2 in front of the ammonia and a 3 in front of the hydrogen. So my moles of hydrogen cancel out, and I'm left with moles of ammonia, which is what I want. So I'm done. I just need to do the math. So I do 2.8 times 2, and I get 5.6 on top and 3 on the bottom, and then I divide that out, and I get 1.87 moles of ammonia. Okay, how many moles of nitrogen are needed to produce 2.9 times 10 to the negative 2 moles of ammonia? So there's my known, and there's my unknown. So I'm going to start with my known, 2.9 times 10 to the negative 2 moles of ammonia over 1. I'm going to put moles of ammonia on the bottom and moles of nitrogen on the top. And I know I don't have this on the screen, but it's the same as the last balanced equation. We're using the same one. There was nothing in front of nitrogen, which means 1, and there was a 2 in front of ammonia. Okay, my moles of ammonia cancel out. I'm at moles of nitrogen, which is what I wanted for my unknown. So now I multiply. So I have 2.9 times 10 to the negative 2 becomes 0.029 over 2. I divide and I get 0.015. Okay, now I'm going to give you a new balanced equation to work with. Same process though. How many grams of nitrogen gas are produced when 1.25 moles of ammonia reacts with nitrogen monoxide gas? So there's my known and there's my unknown. Okay, so this time it's asking me to use something besides moles, but I'm starting with moles. Remember, my steps are the first step to get into moles, I'm already there. My second step is to change into moles of something else, and my third step is to change it into what the question asks for. So the first thing I need to do is my conversion factor. For grams, I look it up on the periodic table. In nitrogen gas, there's 2 nitrogens and they're each 14.01, so that makes 28.02. I'm going to set up my tracks. I start with my known, 1.25 moles of ammonia over 1. I have moles of ammonia underneath, moles of nitrogen on top. When I have moles over moles, I'm going to use my coefficients. So in front of the N2 on this equation, on the right there's a 5. In front of the ammonia on the far left is a 4. My moles of ammonia cancel out, but I'm not where I want to be yet because I want grams of nitrogen gas, not moles. So I'm going to extend my tracks, put moles on the bottom and grams on top. I always use 1 mole when it's with grams, and I added up my grams off the periodic table and I got 28.02. Now my moles cancel and I'm left with grams, and that is what I want, so I'm done. I just need to multiply it out. So I multiply the top and I get 175, multiply the bottom and I get 4, and then I divide. So I get 43.78 grams. Okay, using the same balanced equation, calculate the mass of water produced from 50 grams of ammonia. So now I'm going from grams to grams. So remember, I have to change it into moles first, change moles of one thing to moles of another, and then change it back into grams. So there's my known and there's my unknown. I need some conversion factors. So the first thing is I'm doing grams, so it has to come off the periodic table. So I add up ammonia off the periodic table, and I also need grams of water, and that also comes off the periodic table, so I add that up also. So I set up my tracks and I put my known on top, which is 50 grams. I have to put grams on the bottom to get it to cancel, and moles on top. Whenever it's moles over grams, the mole number is 1 and the grams is off the periodic table. My grams cancel and I'm at moles of ammonia. That's not what I want, so I've got to keep going. I put moles of ammonia on the bottom and moles of water on top. When I have moles over moles, I'm using my coefficients. So I have 4 from the coefficient for ammonia and 6 for the coefficient for water from the balanced equation. My moles of ammonia cancel and I'm at moles of water, but that's not what I want. I want the mass of water, which comes in grams. So I'm going to extend, do one more time. Moles of water goes on bottom to cancel, grams of water goes on top, and that came from the periodic table, and it's always over 1 mole. So I'm going to cancel the moles, and I'm at grams, which is what I want. So now I can solve. I multiply across the top, and then multiply across the bottom, and then divide. And I get 79.31 grams of water. So how many grams of ammonia would be needed to produce 95 grams of nitrogen gas? Okay, so my known is the 95 grams, my unknown is grams of ammonia. Same exact process I just did. I have to change it into moles, change that into moles of something else, and then change it back into grams. So I know nitrogen gas I got on the last page was 28.02, and I have ammonia right above here on this last problem. So I'm going to start with 95 grams of nitrogen gas over 1. Draw my tracks and I put grams underneath so that it will cancel and moles on top. Okay, that comes off the periodic table, 28.02, and it's always with 1 when it's moles and grams. Grams cancel and I'm at moles of nitrogen. That is not what I want, so I have to keep going. Put moles of nitrogen on the bottom, and I'm going to ammonia, so I want moles of ammonia on top. I have moles over moles, so I'm going to use the coefficients, 5 and 4. I cross out the moles, they cancel, and I'm at moles of ammonia. That is not what I want, though. I want grams, so I got to keep going. Put moles of ammonia on the bottom, grams of ammonia on top. I get that off the periodic table, and that's over 1. My moles cancel and now I'm at grams of ammonia. That's what I want, so I can finish now. So I multiply across the top, multiply across the bottom, and divide. And I get 46.1 grams of ammonia.